Okay. Um, Hello, everyone, and thank you for inviting me, first of all, for Man and Machine and SOFiSTiK France webinar. My name is Jung-Hoo Park. I'm from South Korea. I'm architect and at the moment located in Vienna and working for Umdash Group Ventures as a BIM specialist. And today I'm going to present last 3 years of research with SOFiSTiK AG for special thanks to uh, George Fischer and Andres von Bremen and Andreas Nigel. They support me last 3.5 years, this long journey of my research. So today I'm going to present our research as a webinar. So the research part, we've gone through, first of all, Revit and SOPI Plus and SSD, and also integration between Revit and SOPI Plus. And after that, we also integrate some complex geometry from Rhino and Revit and analyze in SOFiSTiK, because some of the complex geometry is difficult to analyze in Revit. And after that, we jump into Grasshopper components, and it developed quite a lot. As you can see, we have now about 6 major component set that you can analyze from building scale to bridge scale. So Grasshopper is like a Rhino interface where you can parametrically manipulate the geometry. And here I used like early stage of Grasshopper component from SOFiSTiK in 2018, April. So like this standard Grasshopper geometry can be converted to analytical model for SOFiSTiK with those component. And as you can see, the Grasshopper geometry surface can be converted to structural area, and we can define the thickness, and also we can give like a group name or member number, and we can also define the support and the member definition from out of Grasshopper. And here Grasshopper is really flexible. We can in real time we can manipulate geometry, and we can define different parameter. It's so-called parametric design tool. And here I'm just defining from the set of points on surface to define the lowest points on surface so that we can get the support condition for SOFiSTiK. So here I'm just filtering the points, and then this support, the one of the points I'm defining load, and then keep manipulating geometry. And after that, all this data we can transfer to SOFiSTiK dot format, and we can insert task in SSD and defining design code, and we can define material and members, and we can here in Grasshopper we can assign one more time, and the export dot extension format can be imported in SSD. And with a text format, here we can type include and then the same file name in the same directory, and then you can calculate the geometry from Grasshopper. And at that moment, I just gave simple dead road, but we can also obviously define, the point road, but we can obviously define all kind of flexibility using text input in SOFiSTiK or Grasshopper different road case definition. In this case here, the model is very complex. It's my university project in 2016. I wanted to calculate actually through Revit, but it was kind of impossible to do it. So I decided to do it in Rhino and then get the analytical model. And through SOFiSTiK, we could analyze. I mean, I'm an architect, so I'm not really expert in structural engineering, but at least I could see where's the biggest deformation when just apply dead road. And I can think about some kind of design options to go further. So I think it's important to collaborate with structural engineer as an architect, because otherwise we cannot achieve the architectural proposal what you wanted to design. So that's the reason why I start to research for this sort of parametric structural engineering. And the SOFiSTiK was really good because I could get all this result very quickly from Rhino. And this example here, I have an analytical model from Revit, and this purple area, this is actually not it was very difficult to get structural analytical model out of Revit. So I decided to model only that part in Rhino and then bring structural analytical model from Revit, and we give linking same origin coordinate point from Revit and Rhino, and we link the same coordinates in SSD so that we can calculate both Revit and Rhino's analytical model within SOFiSTiK. So there's a huge flexibility with SOFiSTiK because you can use multiple platforms such as Autodesk Revit or Rhino and Grasshopper, and you can also use like a Sofi Plus to define complex load cases or more engineering definition for your calculation. So the challenge was here just to find coordinate point, but once you thought about this workflow from the beginning, you can actually just linking the same origin point between Revit and Rhino, and it SOFiSTiK give you really good result by combining those two different platforms. And as you know, in Revit we can define more like the members release condition or fixation. So you can do this sort of structural framing calculation more accurately. And then we summarize all the calculation in SOFiSTiK. Yeah. So to me, it's very interesting. Like not only we designing building as an architect, the prompt result we can check, and this result, I mean, we can just definitely send this analytical model or collaborate with structural engineer together without any difficulties. So that was the main purpose of working with SOFiSTiK with Revit and Rhino. So, and next one is here, architects, we doing a lot of conceptual design with Grasshopper. So this tower scheme, we could like make this sort of small definition in Grasshopper, and in SOFiSTiK plugin, like Grasshopper plugin, we just linked, and here we define some dead road, and then we could calculate it within 12 seconds. And you can see here, just as an architect, we can quickly revise, okay, maybe the core location there, probably it gives too much challenge for structure. Then we can also think about different design options. This is really great because as you can see in Grasshopper, we can change this geometry simultaneously with a couple of slides, and this feedback from SOFiSTiK is also, we just need to calculate once more, and then we get complete different result. So we just shift the core location a little bit and then analyze once more the dead road, and I can get different sort of behavior of structural behavior. So it's very rough, but for the conceptual stage, we can also think about that. And now here I'm introducing Rhino 7. They have this RhinoInside for Revit, so which means we can parametrically design the building scheme or bridge scheme in Grasshopper, and that analytical model we can obviously like parametrically adjust what we need. support condition, footings and stairs, and different building height, or this modular system from Le Corbusier's domino systems that we can array this building scheme for the multiple residential building. And with RhinoInside, now the SOFiSTiK result, we can also convert to native Revit components. So here now I'm going to activate the synchronize the file path component for SOFiSTiK, and we can also analyze the result from Grasshopper. So obviously I just gave dead road. So you can see the result, and we can use just normal SSD function for display and visualization. And now I'm just going to calculate a modular system as a sort of unit apartments scheme. And when I calculate in SOFiSTiK, you can see, so we just need to recalculate these text input and linear analysis, and you can get the whole building scheme in very fast time, and it works really perfectly. So this result, now we can also send it to Revit directly, so the construction team can document initial calculation model in Revit, like such as plans and sections. So now we just, let's say, interpolating the geometry from Grasshopper to Revit, and I just recompute, so we remove the error, and you can see we have now whole native Revit components, which means it's floor slabs and foundation columns and etc., which is great. And here I had researched the meshing was a little bit complicated, so we wanted to optimize the meshing geometry out of Grasshopper, so we can have faster calculation speed and also more like reliable meshing geometry. The idea is that any intersection between the geometry, we need to split the geometry. So like if you do automatic option or single quad or regular options, when we split at all the intersection points, the geometry, then we can use regular option so that we can have really good optimized meshing geometry. So in this case, because it's difficult to manually do when design changes fastly evolve, but when you do Grasshopper, because of the parametric function and it's kind of computer scripted geometrical definition, so any changes is just automatically update, and we can have a look single quad option instead of automatic quad option, and you can see now the mesh is much simpler, and of course the calculation speed is really quick, because right now we are looking at only one module, so it doesn't take much time for automatic option. But when we have when you have bigger scheme, then this optimization of meshing could be very useful. And I think Grasshopper and Rhino gives you really flexible option to optimize this meshing geometry. So you can see here regular meshing options. As you can see, the calculation time is also fast, and we can give a bit dense property for the meshing typologies. And as you can see here, now we have every 50 centimeter has quad mesh. So you can see more detailed calculation. But the point is mesh is really clean. And now I just going to make the building scale bigger with multiple story. So this modular system can be, as you can see, all the intersections split. And now we just do one more time automatic calculation. and you see it still works, but the mesh between the module is very uh, it's messed around, like really it's not very good meshing geometry. But once we make it simple quad, of course, the calculation time is much faster, and the geometry is also cleaner. But maybe the single quad doesn't give you the accurate result. So the best option is to use a regular meshing geometry option, and the mass density we can always control from Grasshopper component. And now when I recalculate, we get very organized, and the between the junction you can see there's no um, such a drama, like a complex meshing drama. So we have really good result we can get, and also calculation time is fast. So now I'm showing some of the project from Point One Studio. Like we worked on this steel and timber structure in Australia. The architect was OSC Architects, and we collaborate with me, and we designed this small single family house. And at the time, I didn't use SOFiSTiK, but I was just thinking, okay, maybe this whole structure we could have calculated initial stage in Grasshopper, so we can have more design variation to come up with the final design. So I scripted in Grasshopper. So as you can see in Grasshopper, we can change all the parameter completely. So the building height and etc. And all the data is structured. So each building component, as you can see, you can jump to the major script to define foundations, and then from foundation you can define support and the how we can graphically organize. It's just a matter of some organization, but it's nothing complicated. And then finally we connect all this geometrical definition to Grasshopper for SOFiSTiK, and then we can, once your design options sort of satisfied, like I don't know, for me here, I can give two different options. One's wing rotation change. Then as you can see, the pitch or canopy on the corner is also giving you a different option. And obviously, we can change the height of the building parametrically, and the foundation height, and all the division for the structural division, and the ceiling height we can also change. So this is very typical case study for Grasshopper, but it's really powerful because the SOFiSTiK calculation result is we can simultaneously update. So here we can, the Grasshopper component, the parameter you can set as many as you want, and this data set is less than 10 megabyte. So this Grasshopper definition, you don't need to worry about many parameters. It's just a matter of how you organize your script, and then how you can talk with the between architects and structural engineer. Then the final result, I'm happy with this design scheme, so I'm just sending the extension, DAT extension file in the same metadata folder from SOFiSTiK. So now let's have a look. Yeah, the scheme is fine. So here I put the text input and referencing that .dat file extension from the same directory, and I just calculate. And in this case, load was applied from Grasshopper component, so you don't have to write a SOFiSTiK text input for the load definition. There are two minor warnings, but it's fine. It's just warning, it's not error. And we can calculate now linear analysis, assay, and then wing. And let's have a look. You can see the two different load case was delivered from Grasshopper to SOFiSTiK. So you can get the calculation. And perhaps maybe I can just send this Grasshopper definition to structural office, and they can quickly have a look the structural result from SOFiSTiK. And then if they ask like, okay, this is not good, here we have to change, then they could also directly change the Grasshopper definition as a structural engineer. And then we can, as an architect, we can get the comments from structural engineer, and we can revise our design based on structural engineer's comment. So there is huge potential for the collaboration point of view, where both architect and structural engineer use this Grasshopper pipeline together. Then the collaboration can be also very efficient. And another project I was working on with M2A architects in Korea, it's a sort of multi-residential building, typical reinforcement concrete structure. And I didn't use SOFiSTiK as a project, but while I'm researching is SOFiSTiK AG, I was interested in, okay, there is a existing like a model in the original model in Revit, how I can use this Revit model to calculate in SOFiSTiK. And it was quite difficult just using Revit itself, because it has quite many building stories, and analytical model to amend in Revit takes a lot of effort. So I have decided that, okay, let's organize model to use in Rhino interface with SOFiSTiK, so I can simplify the sort of structural framing or wall and floor using Dynamo. And Dynamo is like kind of visual scripting interface for Revit. And here we can also sort of extract the geometry, and we can simplify and eventually export this Revit geometry to Rhino. And I just organized the layer structure from Revit. And this is, let's say, is a structural model that I need to convert to analytical model to use in SOFiSTiK. So there was sort of like I could like simplify wall thickness and align center surface to get analytical model out of this wall with using Grasshopper. It's just standard Grasshopper, but we could define all the building components to convert to the analytical model. So the result here is like, obviously not every analytical model came from Grasshopper output. I had to manually adjust in Rhino, but it's still really fast and efficient to working in Rhino than Autodesk Revit for this case, because there's not much constraint for analytical model. So as you see, the organized analytical model, now this podium area, I just tested it with the SOFiSTiK from Rhino interface, and it actually worked quite well. So this research was quite satisfied, and there's huge collaboration potential between Rhino and Grasshopper and Revit and Dynamo. So I know, as far as I know, SOFiSTiK has also Dynamo package where you can read some result from SSD to Revit and display or visualize the result in Revit. And I am hoping to have sort of a research result in the future that where I can use Revit model and through Dynamo or RhinoInside for Revit, which is Grasshopper plugin for Revit, and you can get the result out of the SOFiSTiK in Grasshopper or Revit. And here another example, recently I tested Rhino 7's sub-D. Sub-D is like a flexible geometry between nerves and mesh. And here I'm defining a volume geometry for SOFiSTiK. So here we define part of volume geometry as a support condition. And then we calculate this volume geometry in SOFiSTiK to get result. Because this sub-D geometry is very interesting. We can easily manipulate organic geometry shape out of Rhino, and then we can convert this volume, or let's say solid geometry from Rhino to work in SOFiSTiK as a volume geometry, and we apply like concrete structure and to see how it works. And so far the workflow is really smooth and it doesn't have any difficulties. So I'm expecting to make some probably tutorial or something in my YouTube channel soon for this Rhino's 7th subdivision to SOFiSTiK workflow. And to kind of summarize my presentation today is that Rhino is really eco-friendly. Like it has huge the plugin and community, and you can use your own programming such as Visual Basics or C# or F# or Python, and you can integrate with many plugins like such as you can use Conveyor or Geometry Constru or Excel file as a data interpolation tool, and you can also link to 2D graphic interface, or you can use rendering software. So let's say you could design something and calculate, and eventually you can rendering or display in game engine such as Unity 3D or Unreal. You can also send it to 3D CAD infrastructure softwares, or like many BIM authorizing software such as Revit or ArchiCAD, SketchUp, and there's many plugins that you can export your Rhino model as an IFC model that you can continue the parametric model in such a BIM applications. And yeah, like you could also use your model as far as digital fabrication. So using robot or like, I don't know, milling machines using those software, so you can actually realize your final BIM model through Rhino to calculate, or sorry, to fabricate it. And also there are many BIM coordination which link to Rhino and Grasshopper, and you can also use like different structural calculation software, not only SOFiSTiK. You could maybe initially use Caramba 3D to calculate, and then you can transfer all the data to SOFiSTiK to make it sort of more detailed calculation. Or you can also use your energy simulation. The point is here, I'm not showing all the potential, but the flexibility and the collaboration opportunity between different disciplines, because I would understand building industry is huge and there are more than 50, let's say around 50 different disciplines working together. And if you can have this sort of eco-friendly platform where everyone can collaborate and eventually, you know, realize building and we can use as a facility management, that will be like kind of dream for everyone, right? So I think my part so far, that's it. And if you want to have more detailed information, you can always come to my YouTube channel and ask me questions. And currently I just launched my book with my partner in Korea. This is about construction planning with concrete structure. There are many tips and tricks with Revit to use for structural calculation. So thank you very much so far. That's it from my side.
Thank you, Jung-Ho. It was very insightful.